Okay. Okay. So in last class, what we did is we understood what is time series and data, and how you can create time series or make a time series data using data index. Right? So if index or you have to change the column which has date values to index it. So if you do that, then further like you can do some analysis. So it needs to be made as a time series data, right? So index should be in date format, which you can do either either while loading. You can say that let's say for if you are loading, you can say that index column is month and month contains the date set. So something like that you can do, or you can explicitly mention that index is this column. Okay, and after that, we saw there are three components in data: trend, seasonality, and some error will be there which we can't capture. So if you make a prediction using trend and seasonality, and whatever value left, right? So you will have some true value which you wanted to predict, but you can predict using trend and seasonality, and whatever error comes up, that is error. Okay, trend is it going uptrend, downtrend, how to capture, and seasonality is this repetitive something is repetitive, that is called seasons, right? So this repetitive data you can see um, is season. Now there are two kind of decomposition we can use, classical or STL, to identify trend and seasonality. And so as of now we haven't seen why we have to do that and where we'll use that, but at least we know that we can do decomposition using this STL or classical decomposition, which is either you can use the seasonal decompose, which is classical method. Here you have option to choose additive or multiplicative. Additive means if data is kind of let's say if this is uptrending data, but it's not having varying seasonality. You can think like it's not increasing exponentially. That means trend and seasons are adding up. Okay, so trend and seasons here are adding up, but here it's growing exponentially. So this is where trend and seasons are um, multiplying, right? So something like that you can think like that. So based on that, you can create this seasonal decomposition and identify what is trend, season, and residuals. So this function will give you three things: this residuals, trend, and seasons. Residuals is error only, and you can plot them. So you'll get that okay, it's uptrend. This is the seasons pattern here, right? Like something like that you can do. Then same thing you can do with STL way, but here you can okay, this is still seasonal decompose, but if you use STL decomposition, then you'll have a varying seasonality, right? So that is the benefit of it, that variety will be there in seasonal pattern. It can handle outliers also, and there is one drawback, that it can only handle additive data. So it works like that. Now because we saw what is stationarity after that. So stationarity is let me open that. Okay, so stationarity is if data has no varying mean, variance, or covariance, right? So that is constant. It needs to be if a data is stationary, then it has constant mean, constant variance, and constant covariance, right? So that's what stationary data is. So we have to do the stationarity check before we plot the model, or sorry, before we build the model. And that we can do using two tests. One is ADF test and another is KPSS test, and these are the ways they have built it. So null hypothesis in ADF test is series is non-stationary. So in this case, if we have a p value less than 0.05, then we can reject the null hypothesis, and our data, we can say that our data is actually stationary. And KPSS is the other way around. Like it says by default that null hypothesis that series is stationary. So in this case, you have to get p value greater than 0.05. Okay, so if this is the case, then you can say that the data is stationary, right? So we need to have a stationary here. We should not. I mean, if you wanted to build a model, then we should aim for the stationarity in the data, and that will be given if p value is greater than 0.05 in KPSS test. Okay, so these two tests are there. You just have to import that now. Okay, so AD Fuller you can import from the stats model. So here like something you have to remember, but that's okay if you
So
don't.
your screen is not visible.
Okay. Hello. Sorry, I have rejoined. Right now, visible. The screen is visible. So I was talking that you need to check for the stationarity of the data. And there are two tests: ADF test and KPSS test. And null hypothesis in ADF is that it is a non-stationary data. And if p value comes less than 0.05, then you can say data is stationary, right? And in another KPSS, it says that series is stationary, and we want to have that. So in this case, if p value is greater than 0.05, then we can say that our series is stationary, right? Once we identify series is stationary, then so test is here. Now once we identify that series is stationary, then we can do model building. Okay, so but what if series is not stationary? Then we have to do some form of pre-processing of the data. So we'll see few pre-processing techniques how we can do that. And um, uh, yeah, so and will you use that if required? Okay, so first uh, pre-processing strategies. Uh, so first is you have to, if you wanted to make data stationary, you can apply like differencing in this. So differencing is that you subtract current term, like current whatever value is, um, from yesterday's value, right? So if you do that, it is called differencing. And if you do that, then there is possibility that series becomes stationary, right? So what we are trying to do is we uh, so let's say you have one, two, 3 and 4 in such a way. So current value is, let's say, 4. you're subtracting previous value from that, and previous value from that, and then previous value from that, right? So for this, you'll, for one there will be nothing, like it's like null value, but then 2 minus 1 will be 1, again 3 minus 1 will be 1, and 4 minus 1 will be 1, and so on, right? So this is called differencing. If we do that, then you can see it has made our data as stationary, right? So this way you can make our make a data stationary. Like it's not always going to work, but most of the time, or some of the time, it works, right? So this is one technique that people use to make data stationary. uh, Now, uh, and of course, so we are using differencing, right? So this should be added back while prediction, right? So if you do prediction, then you are going to add um, previous and current terms also. So we'll see how you can do that. um, okay, now that is differencing. Now how you will going to do is, there is one function in the pandas that diff you have to write, and you have to mention the so here you can say diff, and it will do the differencing. Okay, so first is nan, and then whatever, let's say 100. uh, so it goes like uh, so current, yeah, current value is 200, right? Like it goes in the future. So 13th is the next value, and previous one was 1. I mean, here there is some missing values, but don't worry, like in real, if in reality if there is a missing value, then we have to do the imputation, right? So in this case we'll do imputation of so what we do in this case is like we impute all the values in between it. So from 1 to 13, 12 values are, maybe let's say 11 values are there, that all you have to impute, right? So one way is you can use interpolation function, like let's say 100 to 200, and 100 to 200, and you can maybe divide it by 11, and you can start it. So 111 plus whatever is 100 by 11, right? So exactly 100 by 11 or something you can use, and you can increment by that value, right? So there's some ways you can impute, or you can impute constant values. So 100, all of them make, you can make 100, that is also okay. So something like that you can do, but here don't worry, we just consider that this type of data is there. So this is a future value 13, or next value, and previous value was 1. Then the differencing will give you 200 minus 100, and the next value is 300. So 300 minus 200 is again 100, and so on, right? So at this point you have 200 value, but previous value is 400, that's why you have negative 200. So this is called differencing. Now this is we are differencing with a period of 1, right? So maybe you can add few uh, or you can have two periods also differencing. Sorry, this is 12, but you can have two also, right? So now we are subtracting two periods there. So we are skipping one. So 300 minus 100 or something like that we are doing, and 400 minus 200, and then 300 minus 400. So something like that we are uh, doing here. So you can increase periods if you like. Um, if you have, let's say, some data which is repetitive in some nature and all. So you can try out whichever period is, and then you can apply this ADF and KPSS test. So once you do this differencing, you can change few periods here, and then apply KPSS and ADF test to tell you that has series become stationary or not, right? So once you do this, you have to apply KPSS and ADF test, right? So periods are like of, can consider that as a hyperparameter or something, but you have to change that, and test will tell you that is it a good number or not. So okay, so here we have again the same data, which is on the passenger data of airline. um, so which looks like this, and of course, like, so let's say this ADF test and KPSS test, I applied that, and of course, like initially there was we are accepting the null hypothesis that this is a non-stationary data, right? So by default, it's a non-stationary data. And similarly, same thing with the KPSS also, right? So if you, so as of now, we are not looking into why this, what we are using here. Just you should know that this kind of test exists, and you can use that test. Okay. Uh, now, if I apply that, then you can see it's less than 0.05. So this also saying same thing, that I can't, or this is a non-stationary data, right? Now, what we'll do is, first is differentiate, right? So on TF passenger, that is the values of this, I have to apply the differencing. So I'll apply diff, and I'll store it, right? So some way you can store it. So difference you can write and you can store it. So if you do that differencing, you store that. Now for differencing, you can apply this ADF test and all, right. So let's say if I apply ADF test for that, um, so what I'm doing is, so when you apply ADF test, make sure that there are no null values present in the series. So but we will get some null values, right? The first one or initial ones will be null. That's how differencing works. So you have to remove that, and you can store it somewhere, and on that values you can apply ADF test, and you can see now we are very close to a p value is 0.05. But if I, let's say if I give some form of period, a different period, like period equal to 12, because this is a data, it's a seasonal data, right? It is repeating after a year. That's how this passenger data is. So something like this, it's a yearly data, it's rotating. So if I give a 12, you can try other values also and try it, but I have done it, so I know that the 12 will work. um, Series, okay. So if you do that, then you can see now we have a p-value less than 0.05, right? So if you do this, there's a possibility that you might get stationary data. So so this, see, as of now we are only looking for machine learning models which can help you build a, a model using the time series data, right? But sometimes this all will not work, of course, and that time you have no other way than go to the deep learning, right? So but as of now, assume that we have easier data, and we are able to do this. Okay. uh, so initially that's what we can try for the simple things, and we'll see. So similarly, I can apply KPSS test also on this difference, and KPSS test, if you see, that is I guess this not more than 0.05, but that is okay. And so this all test you can apply to uh, after you do uh, apply any form of transformation, and then you can test it, right? So that's what we have to do. Now other form of transformation is before I go into that, I wanted to explain detrending first. Then we'll go into some more transformations later. So what is detrending is that, let's say you have, so we have this passenger data, and what is actually trend, right? So trend is, if you plot a linear regression, right? So a linear regression or line, if you plot that, that's what a trend is. Now how will you get uh, linear regression trend in this case? So what you can do, you so we have imported linear regression, but we need two things, right? So x and y to build a linear regression model. So we have y, which is passenger data, like how many passengers were there in which year, but we don't have any x, right? So as of now, what we can do, we can create x as a incremental feature. So something like this, like starting from 0 1 2 3 4 5 6 7, like it's just a serial number, you can think like that, and values are there for that, and I'm building a linear regression model for on that. So um, that's what it, and trend I'm calling as a prediction, right? So whatever prediction of x as of now, all of the x I'm predicting, and I'm calling that as a trend, right? So if you wanted to do detrending, then uh, you can you can just remove the trend from the y is as of now df passenger values, right? So if you do that, that's called detrending. Simple technique, but it will work, right? So now you can see it's not trending, and earlier it was trending, right? It was going um, upwards like this. Now it's not going. So this might help in making it constant mean or something like that, right? So now the mean will be constant. Of course, it will not be um, like plain constant. Some small values vary, but that is okay, right? So this how you can do. If it works, then you, of course, you have to do the test, right? KPSS test or ADF test to identify if this has uh, really done the job, right? So if we do that, so as of now I'm doing on detrended one, and I have done some form of thing. Like you can see that KPSS is saying that original data was stationary, and detrended is also stationary, but ADF is not saying that it's just stationary. Okay, so um, so just in case if it doesn't work, that is okay, right? So sometimes it works, sometimes it doesn't work. But this is another way you can make or this process you have to do, right? So this pre-processing you have to do. First is try differencing the data. Another is detrending, and third thing you can do is you can do transformations of the data, right? So you can make let's say exponential data was there, right? So maybe it is increasing exponentially. Then you can apply a log on that, which might um, um, it might reduce the exponential of that, right? And make it uh, a stationary data. Similarly, you can apply square root also. If data is maybe it's squaring or something like that, you can take data square root, and you can try on that. Another transformation is called box Cox transformation. Um, if you don't know, that is okay. You don't need to remember, but the equation are something like this, that you try to find y value um, uh, using using this, right? So y lambda you have to find using um, y power lambda minus 1 by I think, and when lambda is not equal to 0. Okay, so what when box box transformation works, when like it's exponential data, so it's kind of you are applying this np log only. Okay, np log, but here in this case the base of log or something like that, you're deciding based on this box Cox transformation. Okay, so if you wanted to read further on this, you can go to this website and read about what is box Cox transformation. Okay, now it will explain you what is box Cox in simple some way. It's up to you, but this what transformation is. Another transformation is that. Now how will do that? So it's just like you have to write np.log and provide your passenger data here. Similarly, yeah, on that you apply for TF AD Fuller test or something. You can see it's not reducing, so it didn't work. But it will work only if data has low variance, right? So if your data has very high variance, then it will not work. So for small variance data, so for example, it has, let's say, trending thing, but not variance, right? So in that cases, it might work. Okay, somewhere it will work, somewhere it will not work. Um, yeah, so I shared it in the. Okay, so all the all the notebooks are there in this folder. Okay, so if you go to this make stationery .ipynb, then you'll find it there. Now, yeah, so I applied log transformation, and of course you can similarly apply square root transformation also, and try apply a test. So that's how it will work. And box cox, how will you apply box cox is you have to um, so from SciPy you can import stats, and then stats has a box cox transformation by default. You just have to give df passenger, but you have to make sure that there are no null, sorry, there are no negative values in this. As of now we don't have, because this data has passenger data, right? How many passenger actually flew in that year. So of course it's not going to be negative, but if some data is negative in your case, then you have to filter it, right? So I'm just doing a filtering, I'm just showing you that filtering you can do, and that you have to apply here. So if negative data comes up, then only you have to do it. Otherwise, like as of now I could have done it without filtering also, and it would have worked. So in this way I'll have a box cox values also here, so it will be stored here, and lambda value as of now I got 0.14. Okay, so in this function whatever lambda value I got, that also I'll get it. So two things that will return: one is what are the values after transformation, and what lambda value it used. Okay, and on that you can again apply the test, and you'll get the result. So this three ways you can do.
So the test automatically applies the lambda, or we have to give lambda from our
No,
side.
you don't have. Yes, it will automatically identify lambda.
What is the
Not test,
optimal RAM lambda it will use?
not test, but box cox will
No,
do it.
no, but what is the optimal lambda it will use?
That it has to identify from the data.
Okay.
Right? So this box cox function will do it. Will do that. Okay, so there are three tests. There are three methods we saw for making data stationary. One is differencing, another is retrending. So initially apply those two. If that doesn't work, and data has low variance, then you can apply few of this, maybe log of the square root of that. So for this, you can maybe look at the data also. If it is going exponentially, or the chart looks like exponential data, then you can apply log or something like that. So in this square root thing also same thing. If it looks like it's increasing in such a way, then you can apply a square root. Um, and box cox, there is no way to identify, but you can apply that on this. But it needs to be have low variance, then it will work. You can otherwise also apply and see if it works or not, but most likely it will not work. Okay, so this three way you can make your data stationary. So once your data is stationary, you are ready to build models. Okay, so there are many models which I come up with, but in this like in this we'll see up to ARIMA. Okay, so ARIMA is auto-regressive integrated moving average. So let's understand what is ARIMA. But before that, um, okay, so before that, what is AR and MA component? If you understand that, then AI, so integrated component is what is differencing, right? So we did the differencing of period 12 to make it stationary. So that period is what I is. Okay, so whenever you build a model, you can use that same 12 thing in the uh, where we did it. Mm, and sure, here somewhere period, right? So this period of equal to 12 I use. That same period you can use. So if you know that differencing equal to some value you have used, and that made the data stationary, that value you can use for I thing. But we have to choose AR and MA components here. So let's first understand what's AR and MA. Then maybe you can do something. But don't worry, you don't have to actually identify what is AR, MA, or I value. What we can do is we can have some grid search method, which will use all these three uh, values from some. You can give a search space, and that it has to search and it has to give a best model, right? So best model will be identified using any of the loss function, but like root mean square or mean squared error or something like that. Loss function you can use and you identify that thing, right? Um, there's something called ACF and PACF plots, which is not a part of our course, but that are also being used. Just in case I just let you know, that are also used to identify these values. Um, but it has been identified that they are not like the best choice. They sometimes work, they sometimes don't work. So anyway, we have to do this grid search technique. So you can directly go there and apply the uh, grid search technique. Okay. So okay, so now our data is still the same, this passenger data, and we have done this decomposition. So what other thing you can do also? So for example, you get result.trend, right? Now you don't need to train the linear regression model like we did here. This was kind of for understanding purpose that we can do retrending using linear regression. But since you have this trend data, you can directly subtract this from the initial passenger data, and you can get a detrended series, right? So that is also another way to do it. That's why we kind of decompose. And sometimes, so as of now, we are not going to look into Serimax model, which is like seasonal component of Arimax. If you have Arimax and seasonal component, then you can do it. So in that case, maybe we need to reduce this seasonal thing also from the like that's called deseasonal series. So as of now, we saw detrended series. Another is called deseasonal series, but we are not going to look into that. But that's why this component is there, right? So whatever components of time series are there, we reduce them one or something, and then we build a model, and using that we made a prediction. We make a prediction. Okay. Now okay, so here again I'm doing the same thing, like checking the stationarity and all. And if you have used um, differencing, then you'll have like making a data stationary. uh, Difference of 12, if you use and apply ADF and KPSS test, you will get both of them as stationary, right? So I'm just printing it out here. Okay, ADF test and KPSS p value I'm storing in a variable, and based on the time I'm doing that. Um, it worked, like both of them gave us stationary data, so I don't need to do anything further. I can directly build the model. But I just show how you can do detrending if needed. So from earlier decomposition, I can get the trend and I can do the detrending. I don't need to build the sklearn linear regression model, because that is same thing as this one. Okay, you can see the data is almost the plot is looking similar, right? This and that this is also detrended. Um, okay, now okay, so now this thing uh, I've added. As of now, we don't have any missing values. Missing values means some dates are missing, right? Let's say first, then fifth is there, like third, fourth is not there, right? So that is called missing value. So in that cases, we have to impute them, but we don't have. So how will you check that? You can maybe you can create a another index thing, and then you match it, right? So is our index and expected index are same? So this difference thing you can use, are the same or different. It will tell you. If it is different, then it will say that there are some missing dates. For example, here I have let's say from fourth I'm jumping to sixth and then seventh, so fifth value is missing. So if you do that, then it will show you that this fifth value is missing, right? So you can write this kind of function to identify that. But in by default case, I would have imputed that using some thing, right? So like interpolation or something like that, I could have used. This thing is same. Now we are at the AR model. What is AR model? So AR is like auto regressive models. So autoregressive means that we wanted to predict something um, using its past values only, right? So, for example, this I mean, I hope you use that's a chat GPT or something. These are auto-regressive models, right? So that's what this model is called. Like if you give, let's say, complete some series something sentence, and it will give you, based on that, it will give you future values and all, right? So whatever is whatever data they have, based on that, it will predict the next one. Right? Exact definition could be uh, predicts future value in a time series based on its own past values, right? So okay, this is a good um, okay. Okay. So if that is the case, then the equation will be like this, right? So you can see it's if you wanted to predict, let's say today, then you can use maybe past value, and before that also, and before that. So you can decide what is p value, or how much back you wanted to go, right? So this p value is like legs, or how many legs you wanted to decide. That is up to you, right? So you can choose that. So AR1 model, or I'm just calling auto regressive one model, is something like C plus whatever this. Okay, give me. So if I'm building AR1 auto regressive one, then what I'm doing is I'm using the first one and then nothing else, right? So this all thing will not be there. So this is called AR1 model. If an AR2 model will have two things, and nothing further, right? So this is AR AR2. So here we are taking two timestamp back. So this first timestamp and two timestamp back, right? So these two values we are taking, and phi 1 and phi 2 are learning parameters. So this thing, it has to learn, right? You can kind of think that this is a linear regression model where 5 are W1, W2, and this is maybe C is a um, some some like
Intercept.
coefficient, intercept, right? So intercept, and then this et will always be there, because that is called noise, right? So we'll not be able to predict this, and what we'll do when we'll do the prediction, will not have this, will not have errors in the prediction, because we can't find that out. That's what we do in linear regression also, right? So some error will be there, but we can't find them. So this is almost same equation, and that's what AR or autoregressive model is. Now, how will we write the code for that? Is that will first do train test bed. Just remember, in this case, we can't use the usual train test bed method from the sklearn, because this data is we have to train a model in such a way that future value can be predicted in past values only, right? So I can't do shuffling or anything. I can't do that. So past values, for example, 1 and this first month, second month data can be used for predicting third month, and similarly second and third month data can be used for fourth month, right? So this way I have to do. So train test bit, I'm doing in such a way that I'm taking last uh, 28 values as a test set, and first 28 values as a train set, right? And you have already seen that this is monotonically increasing, right? So index is monotonically in the, that means there is no jumbling in between it. It is in an increasing manner, and there is no null values present. So if I and I use 20% as a test set, it. So the 0.2 of that is 28 around I'm getting, and that's what I'm using here. There are another ways you can write this function up. That's up to you, but I use this method to write it, and you'll get trained as train data, which has 116 rows, and test data will have 28 rows. Okay. Now few values initially, and you can see difference 12. Now why I have this all, because I have applied all of this um, transformations and I have stored it here. But what is important to us as of now is this difference 12, right? Because difference 12 is the one which has given us stationary data. Okay. Um, don't worry, like other things you can ignore as of now. So in difference 12 or diff 12 column, we have few null values. I can't use that as a prediction. So what I'm saying is that initial few values you can't predict. Okay. So because we don't have it. So diff 12 is something which doesn't have few values, because that's how this function works. So I can't predict immediately after that, right? If I build AR1 model, at least one thing I have to give. So I can start only after this null values are not there. So that's what I'm doing. I'm just dropping it, and after that I have started fitting the model. So in this case, how will you import this? You can call autoreg from model.tsaar. This is same as kind of like linear regression only. That's what we are doing. And lags equal to 1 is the AR1. If you put lags equal to 2, that is AR2, and so on, right? So anything you can do. And other things, like it's a straightforward way how you write. Like you can't change the way you have to write. That's how the stats model have used. You can go to stats model library to see the documentation how to write the code about it, and it will give you a summary. So in summary, what you have to look for is you have to look for this coefficient values thing. This is the constant, which is C, and this is L1 you are getting here, right? So diff 12, and diff 12 is written because that is column name. Don't worry. So this dot L1 is the important thing, that this is 0.7907, right? So let's say you wanted to predict something. Now how it will do is it will take 6.42 something plus this L1 theta, you can consider,
This
and
is the
multiply
phi
it.
value.
Yes, this is pi value. Sorry, pi value. Yes, here this 5, right? And then whatever yt minus 1, you can use that. Okay, so predict. So you can use predict function of this. So what we are doing here, that I'm giving that uh, where it is starting in the df12. You can write it also, that let's say our starting of this is 116 and 116, and last value was 114. This is for test set only. Okay, 114, right? So something like that you can give for the prediction. And we have trained using the whole data, right? So see, sorry, we have trained using train data, and after that I'm making a prediction on test data. But um, give me a minute. uh, yeah, so this is the next prediction. So it has so how it happened is that after train got over, the first only one point, I can only predict for one point only as of now, right? Because that much data I have. I don't have any future data, right? Let's say I have 0 to 116 data as a train set. Now I can only predict 117 because I need 116 data, this row, to predict it. Now I don't have anything as 118, right? I don't have that, but I can use 117 for that. which is my prediction, and I can do it, but it will give you incorrect answer. Like, of course, this 117 has some mistakes. This error term which we didn't include it here, right? That error term will be there, and based on that, so uh, yeah. So if you wanted to predict in more future something like that, you can use uh, you can use multiple values of this, right? So yt minus 1, yt minus 2, yt minus 3, yt minus 4. You can go a little back, and then maybe you will be able to predict a little further, something like that. You can do. And if you plot it, so if you plot this, so in this case, what we generally do is, whatever prediction I got, I don't extrapolate that. I can use, of course, I can use this thing to predict 118, but generally we don't extrapolate, but we'll kind of give them same values to all of them. And if you plot it, it will look like this, right? So this is how my predictions are going. And yep, right. So this is how my predictions are, and you can see it's not doing very good job as a AR1 model. You can maybe try another AR2, AR3. So what we can do is we can create something like yeah, we can create something like this, that for lag equal to 1 to 25, it's like a grid search thing. I can't use grid search here. That will work in sklearn only. So I can mention this, and here for lags, all the lags, I'm storing a value. Now, this AIC I'm using as of now, but don't worry if you don't understand that. The function of AIC is something like 2k minus uh, yeah, so something like this. Okay, but don't worry, as of now we are this is by default there in the function, right? So that's why I'm using it. But if you don't understand, that's okay. You can create something like mean squared error, and then also you can compare it. So this just for making it easier, nothing else. But at last, when we'll build the arima model, we'll test it using mean squared error only. Okay. So this is a new loss function. You can think like that, AIC, and this is being calculated this way. Okay. Uh, Now, if you do that, then for AIC, sorry, for 24 lag 24, you will get the best value of the model. And if you plot it, I guess here, so if you plot it, you can see it is little better than the AR1, right? So because AR1 can't do uh, can't go much into the past, right? So that's why it will not give you best value. So you need to use some lag values to predict it, right? So here you can see it is little better than the AR1. Okay, so this AR24 model we have built, and this is how you can build a auto regressive model. Okay, so what you have to do, you have to do a train test split, and then choose the lag values in this auto regressive thing, and you have to give your train set, right, and lag value, and based on that you can plot the graph. So graph plotting the graph and all, you can look into this, how to build it. And predictions you can make using this, right? So predict function is that you can give how much predictions you wanted to make. So now we are making prediction for test only. For train you can also do that, right? So similarly you can do for train also, if you like to. But generally we don't care about how training prediction is in this case. We only care about test prediction here. uh, okay, now that was auto regressive model. Now next model is moving average, but like um, there is no library which actually build only moving average model in stats model. So what I'll do is I'll use arima, and as of now don't think much, but you can see the first term, whatever AR you have used, you can give here. This is of differencing, and the third component is of moving average, right? So this three component you have to choose when you build the arima model. So I've kept other as zero. I'm not considering them. It's like I'm saying that AR is zero and differencing is zero, and then I'm doing it, right? um, and I'm giving a train series. So train series again, same thing. I think I made here train series as a train TF, right? So I've changed that name here just for sake, easier thing. But yeah, so the code wise it is almost similar. You just have to import the arima, give your data. Here you have to give something called order, not lags, and then you can fit it, and you can use summary to print it, right? So here you can see the L1 value is this, constant value is this, but now equation is a little different. Okay, so earlier I have phi thing of AR, but here it's a theta. Now I'll explain what is moving average to you. Okay, not okay. So what is moving average? How does it work? First, you find the mean of the series. So whatever your train data is, you kind of take train dot mean. Okay, and and then what you do is you identify how much error or how much error you have from the mean. Okay, so for next point, you give that and you try to identify what is error, and you kind of learn that error. Okay, so let's say error is of 2, let's say next prediction is 102, and mean is 100. Okay, so you said that I will predict next word, next timestamp, that is going to be 100 only. So my prediction says 100 because my moving average is 100. Okay, uh, this is true thing. So I made an error of 2, right? So error of 2. I'll give this error of 2 to the next one, which is something, right? So let's say next true or next true is 104. Okay, next true is 104. I'll say that my model or my prediction will be first I'll say my average, which is 100, plus some error, which is 2, and I have to multiply it with some theta, right? So this theta I have to multiply here. Okay, so for first one, of course there will be nothing I can give as a error or something. So for that it will just give mean as a value, but after that it will have this uh, error and theta 1. Okay, uh, yes, so something like that, right? So this is how you build a moving average model. But so in this case we will have two things. So you'll have the summary. What you should look into this is what constant value you got. This is average of the series, and how much theta is there. Okay, these two things will be important, and based on that you can build a model, or you can make a prediction based on these two things, right? So as of now we have used MA1. You can give MA2, MA3. So based on that you'll have multiple this constant values also. So as of now one thing shown here, but if you have used 2, then it will show you ma.l2 also. Okay, so L2, L1, that's how this they use the uh, used to define this constants. Okay, now you can see the series, the train series has mean of 29.17 by if you calculate, and this is 1 1. I mean they are very close. Maybe some error due to the way it is being calculated, because we are using arima and not exactly the mean, right? So some difference is there because I've used arima model to build this. But anyhow, with this it is almost similar. Okay, now same thing you have to do. You have to make a predictions, and then you have to plot it. So if you do that, you'll have the plot. So here you can see very constant, because um, after certain, like MA1 I'm using, so after one point we are not going to change it, right? So whatever it's at, we will say that that same thing is the one, right? um, will not change once training set is over. uh, so this is how you can train MA model. Now this was just a you can say kind of milestone to build a ARI model, which is the main model of this time series analysis or forecasting. That whenever you are going to forecast, you are not going to build AR or MA model. You will completely ignore them. You can kind of ignore them also. The model we have to build is ARIMA, and how you build is again same, nothing I'm changing here. You have to import this ARIMA. I think it's being imported somewhere here. Okay, it's we imported for MA, and like we build like we build MA model, same code, nothing is changing here. Just to uh, here I didn't mention, but the first component is AR, right? So you can maybe give AR equal to some good value, let's say 24. Earlier we saw that that was a best one. Now differencing you can give, let's say 12, because that made this as a uh, stationary data, and I can use some moving average. Okay, and you can see I can use something like direct TF
What is
passenger.
AR?
Sorry,
What is AR here?
autoregressive.
Okay.
Autoregressive integrated moving average. So the first one was autoregressive, right? So AR component of that lag of whatever we used, right? And this is due to differencing.
So can you re-explain that moving average theta one again?
Okay, so what how we'll build moving averages? First we take a mean of the series. So this y is there, right? So this blue one you can consider. Now some moving average is there. So moving average, sorry, not moving average, but some average is there, right? So you take all the points and find the average of this value, a mean of that. As of now we are getting 29 using this. Now from the 29 I plot, or I try to find how much error I'm getting, right? So some error I will get, correct? That error is what I should have added so that I can make a correct prediction, right? So that error I'm learning. So how much error I made in a previous timestamp, and then how much error I made in before that, and before that, and before that, something like that. So you can consider how much back you wanted to go to identify this, and some error will not be able to identify it. So this last one is the one which I error I'm making in the current time step. Okay, so this much you can learn, and that's how the moving average uh, model work. A model is built.
So the number of I mean the if you take only one, then this is the last one.
Yes, the last one. Uh,
Okay.
yes.
So here you have
Um,
taken only one.
yes, the only one, the last one only.
So 102 was the last one. 102 was the no there.
102 means
So there you have explained in that. Go down, sir.
okay,
Not here. Above.
okay, above.
Sir, there you in that text box you have explained now. No,
Oh,
bill.
okay, I understood. The last one, right? This 212.
No. That
Uh,
102 100 you have written 100 102 you have
oh,
written.
okay. I understood. This one.
Yes. So
This
a
one.
mean was 100. And
Yes,
what
mean
is
was 100.
true? What is true?
True means whatever yt is. Now, let's say I wanted to predict yt. So I need to take error t minus 1, to um, predict that, right? So let's say at that point my error was 2. Uh, right. So for 102 prediction, I need two things, right? One is moving average and error. Now I can, using that I can predict yt hat. Okay, so you can say hat here. I want to identify the, how will I do that? I'll say that 100 plus my error in this thing, which is 2, and I have to learn that some theta parameter I have to use to learn that, right? So this is my error from mean. I have made this much error.
Okay. Now for the next one.
So for next one, my, so see, I have the true values, right? So y true is for training, at least I will have. So if I y true for next one is, the next true is I written as 104, right? Now it should be theta and some error I made earlier, right? So whatever error I would have made earlier, maybe it could be 2, 3, anything. So all the errors I have to include at one at a time in this case. Right? So error between this next and the previous one, that or maybe uh, uh, yeah, something. It could be 4, right? So something like that. Uh,
So, sir, it will be a different theta, and the error will be error at t minus 1 and t minus 2.
Theta, no, theta won't change. Theta will be once learned, then theta is constant. But this errors will change. So error will be changed once. So error is like from previous timestamp, what error you made, then what error you made again, and so on. Okay. So while learning the moving average, it only uses past some data, something like that. Now, okay, see moving average prediction. So yeah, okay. Actually, I never explained what is simple moving as exponential moving average, but um, so okay. See, this is MA3, right? So 3 MA they've used, but we have used 1 MA. Okay, so we are only taking last MA only. Now this red curve is a thing. Now you can predict. Now you can find what is error in between, right? At each point you can find error. That error I'm talking about. In this case, right? So let's say you wanted to predict here, right? So this point, then whatever error is there in this case, you will use that, uh, or maybe whatever is in previous case, you can use that and then learn on that. Okay, so um, no, this is just a moving averages. Okay, don't worry. Like this is uh, forecasting. Yeah. Okay. After that, it's on the ARIMA model. Directly they'll jump to there. By the way, yeah, this looks uh, okay. I think there's no example here, but uh, yes. But what we have to do is we just have to find the, or we can use the errors it has made in the previous thing using moving average. So MA1, you can, if you take MA1, that means you are taking, you're not taking much to back, but only 1 point in the back, right? So let's say previous. Okay, let me start with the first. That first we compute the mean. Let's say mean is 100. Okay, so train dot mean is 100, and my first point. So this is my first point, which is 102, and this is my second point, which is 104. Okay, so this much I have now. Now using moving average, I can find the error. So moving average is, what you do is, let's say moving average of 3 is there. Okay, so let's say my third point is 106. Okay, now moving average of
Take 1 point below 100 also, sir, because point
uh,
can be below 100 also, right?
yeah, it can be, yeah. So let's say we have 98. Okay, now that is fourth point. Okay, so now let's say you wanted to find moving average of 3. Okay, so what is moving average of 3 is, you sum all three, this 3, first 102, 104 and 106, and you divide by 3. Okay, so that is there. Now the window will shift, so window will come here after that. So that's a moving average. So, or like by default average is, you take all the average, you take all the value and average. But moving average is something, window, you decide window size. That is what this MA3 belongs. The 3 size window I'm taking, and I'm taking average of that, then it will shift to another 3, and then I'll take, and if I go further, then whatever is next 3, right? So that's how moving window will work. So this averages, I'll get some averages, right? that
The
that averages,
104. 104, sir.
Yeah, so in this case it's 104 for the first case. Then next case it will be whatever is 98 plus 106 plus 104 by 3. That could be some number, that thing I'll get. So that's how my moving average will be plotted, right? So this red curve you are seeing, okay, not here, but in moving average, I don't know where it was, but yeah. Okay, somewhere it was, right. So the red graph you are seeing, that's what you'll get, right? So at each point you can find the moving average, that you can do. Now some moving average will be there. So let's say I wanted to predict for MA3. Now first 3 point I can't make a prediction. Okay, I can only make a prediction for 98, because I need, for this point I wanted to make a prediction. So what I'll do, I'll first use some average, which is 100. That's what I'm saying, because the whole series average is 100. Right now, as of now, I have 4 points, but just consider I have more. And plus I'll take some learning parameter, so that is theta 1. Okay, now what error due to moving average? So as of now 104 is there. So um, um, okay, at 98, sorry, at 98 some other value you can consider, right? Like um, or maybe just take 104. Let's take 104. That is our average. So 104 is our moving average. So 104 minus 102, that is 2. So that much I'll multiply, plus theta 2, and multiplied with 0, plus theta 3, and multiplied with minus 2. Okay, so something like this you can do, and some error, more error you might get, which is just error. So this is how you can identify this is value. This for MA3. But if I would have used MA1, then I have to just take whatever is error between like previous and previous to that, right? So which is 2 only, just 2, 106 and 104. So one window you will go, and that much you can choose. Okay. Yeah, so for this, let's say if MA1 is there, then error is how much error I'm making, moving average, right? So 1 point I'm taking, so 2 is the average or mistake I'm doing, 2 here. In this case I'm making a lot more, like maybe 8 or something, but that will come in the next part only. Say fifth one, if I go, and it is let's say 100 itself, that will be 100 plus the error I'm making is a lot more, like 8, right? So theta 1, theta 1 star 8. So this is how MA1 works. So more MAs, then that much uh, back you go in this. Okay, and error you compute based on that. Okay.
So here 102 you will not be able to have any value 102.
No, that is the initial point. For that I can't predict.
Okay.
But
I
in
need
this
at
you
least,
can't, sir, because
sorry,
we are subtracting it only from the mean, not a difference between the point and the next point.
we are differencing from the mean. So see, as of now, the mean. So this here the mean is moving average. Okay. Sorry. Yeah. The mean. What I'm calling mean is the data is mean. The whole data you take average of that. That is mu. Okay. Now moving average is something which moves with the data. Okay. So for this three value, if you take a mean, that will be different. For next three values it will be different, and for next three values it will be different. So that's called moving average. You move with, or your average moves with the data. Okay, so here you have defined a window size. That's how moving average works.
Sir, but is the size fixed or is it dependent on error wise? I mean,
So
stepwise
size, no, size you have to decide, right? So MA3 I'm using, that's why 3. MA4 I'm using, that's why 4. So now how will you decide that? You have to use, like earlier we did this thing, right? That for I equal to 20, sorry, for lag in range of this, I'm building all the models, I'm predicting it, right? So what will be the best values? I don't know. I will use same thing, and I'll give this ARIMA model into that. Where was it? Yeah. So this ARIMA model, and I'll call this as a lag value or MA1 value. You can add it here. Okay, and then build all the models and find best one. So same
So
this
for
same
MA1,
yes.
suppose you cannot predict for 102, but for 104, it will be 100 plus
Yes.
theta 1 into the difference between 104 and 102, right? That is 2.
Yes. For MA1 case, yes.
So 100 plus theta 1 into uh, 2. For
Yes.
106, it will be 100 plus theta 1 into again 2.
Yes. Again two. Yes.
For
In this,
98, it will be 100 plus theta 1 into minus 8.
yes, that should be -8. Yes.
Yes, I got it now.
Okay. Here too. Yes. Um. So
And
yes.
these thetas are what we are learning from the algorithm. Thetas are what we are learning from the
Yes,
algorithm.
that we have to learn. So thetas will be, we have to learn from the algorithm, which ARIMA will do it. So it's like kind of, you can say we are training or we are fitting linear regression model, something like that, but it's little different. Okay. Uh, yeah. So you can use this ARIMA model, which will learn this theta. It will give you what theta values it has learned, and what is
And
the
ARIMA is a combination of the auto regression, MA as well as I. You
yes,
can you
yes.
can keep different values of AR, I, and MA.
Yes, correct. So this order is something there. So first one will always be used for AR, second will always be used for differencing, and third is used for MA, moving average. Okay, so this is how you have to always use this. They might use PD and Q somewhere in books or somewhere, but that is same thing. Okay. Yeah, so we built the MA model. Now we just have to combine this three thing. First, we saw the differencing part. I mean, we can't build a model on differencing, but we can do any AR or MA component. Now we have to combine them. So same thing, whatever we did here. As of now, what we saw is we just use 1 year, but you can change this for AR, differencing, and MA, and then build the model. And similarly, you can have this. Okay, so same thing you have to do, nothing different you have to do. But just one thing which is left is you have to do this grid search CV, right? For this, which you can do, which for which you have to write these loops. So how many loops you have to write? You have to write 3 loops in this case, because here one loop is for one thing. Now, if you do grid search CV, you know that let's say you have 4 parameter values of first parameter value, and another 4 or another 3 for the next parameter. You'll get 12 different grids value, right? So 12 different models you have to train. So similarly here also you can do that, but in this case we'll write 4 loop for this, right? So 4 1 and another 4 you will write, same thing you'll do, and it will have 12 loops. Okay, so 12 models you'll get in this case. And third, but our case we have three things, right? So one is P, or then one is AR thing. You will use some, choose some values. Then for D also you can choose, or sorry, for I also you can choose some values. And then MA also you'll choose some values, right? So
Loop
4
within
and
a
all,
loop within a loop.
yeah, loop within a loop within a loop, yeah. So if you write that, then you'll have this grid search way, and you can do that. Okay, so I think I'm haven't done that, but that's how you have to do it. I haven't searched for any library which can do it for you, but you can search for that. That is there any library? And I'm using mean squared error or root mean squared error, anything which you like, to print the error. So earlier we saw AIC. If you don't understand, that is okay, because we will not use that. We'll use moving average, which is understandable to us, easy. We have learned this. So root mean squared error to identify that. And um, yes, and you can plot it, right? So somewhere, okay. Okay. So okay, so see, all of them mentioned that this is Sari max result, but don't worry, it's a ARIMA only. I think that's how they have built the summary function of that. That it will print Sari max only, but we are only learning till ARIMA, because seasonal component is a different game. Like for that, a lot of prerequisite will be required, or maybe something like that, right? So
So what is the result of that ARIMA? What is shown in that?
yeah, so ARIMA, if you plot, then you will have this kind of curve, and these are just a confidence interval, right? So earlier we didn't use any confidence interval, but you can have confidence interval. So how much error you make and all, you can plot that.
So theta and phi we are not getting with the help of that.
We are getting, so this AR L1, which is phi 1, this is phi 2,
Okay.
this is theta 1, theta 2,
Okay.
and uh, somewhere it should be giving you mean also. uh, I guess not mentioned here, but somewhere you'll get mean also, and or maybe uh,
So we have kept it as 2, right? That AR and MA we have kept it as
yes,
2.
yes, 2 and 2 right here, and differencing I'm using 1, but you can change it, right? Maybe you can have 20 12 also here, and you can have 24 in this, and similarly you can have moving average also, something, right? So try out whatever values uh, will give the best result, use that, right? So for that, I mean, as of now, what we did is we checked AR individually using this loop, right? So that's how I know that 24 is the best one, um, or something like that. And similarly, MA also you can do, and you will have some value. You can use as of now that thing, but instead of doing that, you can directly put all three values here, in a loop of for loop of three things, like for loop, for loop, for loop, and then try it out. So that way you'll have trained all of this. You can store some value somewhere, and then print it, right? So same thing, whatever we did there, similar thing you have to do it, but just you have to write loop again and again. Okay. Yeah, so this is a ARIMA of 212, and yeah, we haven't included seasonal terms
And
in this.
the error you have to minimize by using the different parameters. You have to
Yes,
minimize the error.
yes, you have to minimize
Needed.
this error. Yeah, so whichever has the low error, you you can use that for as a best model. Yes. Right. So when you do this, you can, so as earlier we stored AIC, right? So AIC loss we use, but when you do this, you can store mean squared error, anything like mean absolute error is there. You can store this, and for all the models, you will have this value, right? Mean absolute error, and then whichever has the least mean absolute error, you can print that. So all of these things are just the for loop part. You have to do it. Okay, it's I'm just leave it up to you to write that. And I guess, yeah, so that's all is there in time series. So I just summarize it, that how you will build this. You will load the data, you will do decomposition. So this decomposition will help you in detrending and all later on, but nonetheless you just give a visual uh, look to it, that how my data is. So this is my trending. Okay, this is how I'm getting a seasonal patterns, and there are some errors is there, right? So if you say lots of are there in between, then it's a good thing, right? So it's a good sign that you might will be able to easily achieve a stationarity in the data. But if it is very worrying, it's not close to this middle line, then you might face difficulty in getting data stationary. Okay, now after you do that, you do check on a stationarity. Then if it is stationary, then you just directly go to the ARIMA model and build it. Okay, there is no nothing you have to do in between. But most likely you will not get it, and in that cases you have to make the data stationary. So either one of this transformation you have to apply, difference in retrending, or this NP log, or square root or something, right? So box cox, anything you can do. And once after doing that, you again check for the stationarity ADF KPSS. If you have done that, then once you get the model, you don't have to do this AR or MA model. You can directly go to this ARIMA model and you have to build it. Okay, so AR and MA was there to understand what is going to happen in ARIMA. It's just a combination of this three. Now we are not looking at ARIMA model equation, but you can think like it is combining in some way, right? So how it is combining, that we haven't looked, like is it multiplying, adding, what we are doing there, but we are doing something, right? So that's how ARIMA works. We know the component of it, but ARIMA itself is not. Don't worry about that. Okay. Yeah. So that's all you have to do in time series data. Whenever you get a time series data, you have to check that. Just one thing you should always be careful, that whatever the frequency of your data is, let's say if it's a monthly, weekly, daily, is there any missing value in between? So now earlier we saw that missing values were represented as null values, right? np.nan or something like that you might get. But in this case, you might not see np.nan. What you might see is that the whole date is missing, right? So that if date is missing, that is null value. Now you have to, most likely you have to impute that. Okay, because you can see that for predicting yt in, let's say, AR model, if we talk about uh, here, right? So for predicting yt, you need every consistently difference timestamp, right? Yt minus 1, yt minus 1, which by default I'm assuming that it is past. Let's say today's data is there, then yesterday's data and day before the data is there. Okay, that's what by default assumption is. But if there is something missing in between, then your model will not likely, like, will less likely to work, right? So that, for that reason, you always have to impute missing dates in this case. Yeah, so that's all is there for the time series analysis and forecasting. Now,
What is TSA, sir? What is full form of TSA?
uh, that is, I guess, time series analysis only.
Okay.
Here, right? So that stats model you can use. So stats model has for many other thing also. That's why they use for time series specifically. They build this TSA. Yeah, see time series. Okay, see here, yeah, it's time series only. Okay. Yeah. So that's all is there. Now the link I have given, I will just share it again. And somebody has joined later. All the notebooks are there.
So in the
I'll
discourse, this will not be available in the discourse
in the
or in the contents, course
it
contents.
should be there, but I don't know why it's not there. It should be there. I'll add it. I'll tell someone to add it. Okay then. So that's all I have for today's class. If there is anything you wanted to ask, you can. Okay then. We can close the session. Goodbye, everyone.
Thank you, sir.
Thank you, sir.
Yeah. Thanks, everyone.